Good morning to all of you. We have Yesterday we have seen the types of nuclear reactions, that is elastic scattering, inelastic scattering and photonuclear reaction. Today we are going to see the radiative capture, next type of nuclear reactions. Here the particle on capture leads to the emission of radiation in the form of one or more gamma photons. Means here the ejectile is the gamma photon or gamma radiation. The most common are N gamma reactions. In which product is an isotope of target element 1 mass unit higher. In N gamma reactions, product is an isotope of target element 1 mass unit higher. So for example, when sodium 23 interacts with neutron or strikes with the neutron, the ejectile here is the gamma radiation. This is again the projectile, this is ejectile, and the target product nuclei is the isotope of the target with 1 mass unit higher. Second example again of phosphorus 31, when undergoes N gamma reaction, it gives the product phosphorus 32, which is again 1 mass unit higher. Similarly here, N gamma reactions have been realized with very large number of target nuclides. There are also some P gamma reactions, as phosphorus 19 when strikes with the proton, ejectile is again the gamma radiation and the product nuclei is here neon 20, which is 1 mass unit higher, but it's not the isotope of the target. These are the different reactions, P gamma reactions. In P gamma reactions, the ejectile is gamma photon or gamma radiation. Here is also the ejectile, the reaction in which the emission of radiation in the form of one or more gamma photon is called as radiative capture. So all these reactions wherein the ejectile is gamma photons are known as radiative capture. Second, next type of nuclear reactions, these are the other types of nuclear reactions. Large variety of other types of nuclear reaction is known as PN, NP, N alpha, alpha N, NDP, DN, alpha T. P means proton, N means neutron, we know. Alpha means helium nuclei, D means deuterium, and here T means tritium. Special nuclear reactions. In all the above nuclear reactions, product nucleus differ from the target nucleus only by a few units of A means mass number, or Z atomic number, or N means neutron number. So in previous types of nuclear reactions, we have seen that the product nuclei is somewhat different from the target nuclei. Product nuclei is somewhat different from the target nuclei, or here in this case isotope, but only by a few units of A or Z atomic number or mass number. So difference in product and target is of only few units of A or Z. A means mass number, so here mass number difference is 1, here mass number difference is 1, here mass number of difference is 1, and atomic number is difference is also very much less. So we have seen only the nuclear reactions having the product nucleus differ from target nucleus only by the few units of A or Z. But there are on the other hand many reactions involving high energy projectiles in which target nucleus is partly torn apart or break apart, yielding the products lighter by the several units. Some of these are listed below in order, so let's see which are these. So first of this type is evaporation. In this case, high energy projectiles in which target nucleus is partly thrown apart or break apart. So target breaks and yielding the products lighter by several units. So in evaporation, when several nucleons or their combinations as alphas leaves the nucleus, the process is referred as evaporation. So when the ejectiles are uh, in numerical numbers or in large numbers, when several nucleons are in several number, when ejectile is in several number, then such process is called as evaporation. For example, the cesium 133, when strikes with alpha particle or helium particle, 4 neutrons are ejected and the product is again lanthanum 133. So in this case, the several nucleons are or ejectiles are there. In second example, aluminum 27 when interacts with deuterium, proton and alpha particle is emitted or ejected and the product is here sodium 24. So here in this case, one must know that the conservation of nuclear charge is always must be present in every represented reaction. So you can tally this conservation of atomic number of aluminium, then atomic number of this deuterium, must sum of these two must be equal to the sum of these two. Second type of the special nuclear reaction is spallation. This is more violent than evaporation. In evaporation, several nucleons are ejected. This is more violent than evaporation. Large number of nucleons are thrown out and product nucleus is very much lighter than the parent. So in this case, you can see here, for example, large number of nucleons are ejected. For example, copper 53 when interact or strikes with proton, the ejected particles are proton, 3 neutron, 9 alpha particles and the product is sodium 24, which is very much lighter than this. Here is also the uh, product is very much lighter than the target nuclei and large number of nucleons are ejected. Such reactions are called as spallation. Second example, bromine 79 when strikes with the proton, so number of particles are ejected or nucleons are ejected, leaving behind the scandium 44. Third special nuclear reaction is the fission. As we already know this, fission is the process in which nucleus excited by a neutron. Fission is the process in which nucleus excited by a neutron or by other means and breaks into the two fragments of comparable sizes. So the in fission process nucleus excited by the neutron or by other means. This is the excited state of this uranium 230. When uranium 235 strikes the neutron has 0 1, mass number is 1, charge 0, so mass is increased by 1 unit 236 and the star represents the excited state. So in fission process nucleus is excited by either by the neutron or by other means and breaks into the two fragments of comparable sizes. So it breaks into the two fragments of comparable sizes. This number is uh, typing mistake. So I am with emission of two neutrons. So fission is the process in which nucleus excited by the neutron and breaks into the two fragments of comparable sizes. Fourth type of special nuclear reaction is the fragmentation. In fragmentation, when nucleus on heavy excitation around 0.5 giga electron volt, when nucleus on heavy excitation around this much of energy of the projectile splits into the light and heavy fragments having about the same n by z ratio as in the parent, and the process is referred as a fragmentation. or star process. Excitation energy not being equally distributed between the light and heavy fragments, and the former decays by the beta minus and later by the evaporation. So this process also followed by the fragmentation process. In fragmentation, nucleus excited heavily by high energy projectile, and that leads to the light and heavy fragments having the same n by z ratio. This process is called as fragmentation. The next process or special type of nuclear reaction is a transfer reaction, or it is also known as stripping and pickup bookshot hypothesis. Here, the projectile does not react as a whole with target nucleus. Projectile, in previous reactions, we have seen that the projectile is wholly reacted with the target. In this case, projectile does not react as a whole with the target nucleus, but one or more constituent of the projectile alone are captured by the target nucleus. In this way, products heavier than the target are produced. With accelerated deuterons as a projectile, they behave as if they are made up of the proton or neutron. So, sum of proton or neutron is nothing but the deuterons, sum of protons. Here, this is the projectile, and that projectile does not react as a whole with the target nucleus, but this deuteron reacts as a one or more constituent. That constituents are proton and neutron. So it breaks into the proton and neutron, and that each has been captured by the target nucleus, of which either alone is captured or more often the neutron is captured. These are referred to as Oppenheimer-Phillips reactions. These are referred as Oppenheimer-Phillips reactions.